Hello friends, this video on metal and non-metal part 17 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 16. Now let's start with a new topic called corrosion. What is corrosion? So when iron is exposed to a moist air for a long time, it gets this brown flaky substance, right? This guy is called rust. And this process is called corrosion. So what happens in corrosion? If you see iron, it reacts with oxygen. It gives Fe2O3. Correct? You can balance this. So this becomes 2Fe and 3 by 2. Yeah, this is the Fe2O3 is the reaction. Correct? So this is nothing but my corrosion reaction. This guy is rust actually. This guy is rust. And this is a very painful thing because a lot of time we buy something and it gets corroded and it's waste. The strength of this article is gone, it's weak, you can't use it anymore, it looks dirty, it looks dingy actually. So this is something which you don't want, right? This is something which is a unwanted thing and we always want to avoid corrosion. So let's see what we can do on that. So what is required for corrosion? So we know that both air and water is required for the corrosion. Correct? So to prove this, what we can do is we can take 3 test tubes. In this test tube, we have put this nail, and this nail is exposed to both air plus water, right? Because there's air, there's water. This guy is put in distilled water, and you have put this oil layer, so that there is no air that comes to this water or comes to this nail. So that here we have water but no air, right? Here in this case we have put calcium chloride, and this is dehydrating agent actually. It will remove the water, it will absorb all the moisture actually. So here we have air but no water. Why? Because all the moisture in the air is absorbed by this guy, dehydrating agent actually. Okay. So what we'll see that we'll keep this for 2 or 3 days. We'll see that this guy got rusted. This guy got rusted. This guy got no rust. This is also no rust. So in this case we provided water but still there was no rust. In this case we provided air but there was no rust. In this case we gave air and water both and it rusted. Thus we conclude that both air and water are required for this corrosion. This is an experiment you can do in your home also. You can have these 3 test tubes, put this in water, right, and it will have this air also. So this has air, water both. Put this in water, put the oil thing so that there is no extra air inside that. This has only water. Put this some calcium chloride you can get from lab and put this in the test tube, close all, and after 1 week or something you'll find that this gets corroded and this are all fine. So that's the message we have got, and the key we have got, that both air and water is required for corrosion. So we can stop one of these, we can stop corrosion, right? So we can stop corrosion by painting, oiling, greasing, galvanizing, chrome plating, anodizing, making alloy. So painting, we know with painting the layer of paint and water and air both are avoided, so there is no rusting. In oiling also we have a layer of oil and there is a air avoided, right? So you can avoid this. Greasing also does the same thing, right? So you can avoid this water and air. These all things we know. Galvanizing is something which is new to us. We'll learn this. Chrome plating is plating a layer of chrome. Anodizing is also new to us. Making alloy is also new to us. So we'll learn all these actually, right? What is galvanizing, chrome plating, anodizing, making alloy, and how these things help in preventing corrosion. So first thing is galvanization. Galvanization is the method of protecting steel and iron from rusting by coating them with a thin layer of zinc. And I'll tell you, it's a very critical thing. Why we coat with the layer of zinc? Why don't we do with the paint? We can coat anything with the paint also, but something like utensils, if you coat with paint, the moment you heat it for cooking something, the paint will burn, glow off. So we can't coat with paint in such scenarios, right? So we have to use something else. So in that case we use this zinc, and this process is called galvanization. correct? So, and zinc here acts as a anode so that it cathodically protects steel. That means even if a steel is scratched or broken, the zinc part is scratched or broken, it will still prevent. The zinc will still prevent because zinc will act as anode. It will still prevent. Let's explain this why. So the method of galvanization is like this. We have two methods. One is hot dip galvanization. The other is electroplating. See, I'll tell you how this sacrificial thing works. So if you see Fe, when reacts with oxygen, becomes Fe2O3. So gradually what is happening is Fe is becoming positive, right? So iron is losing electron for corrosion. Correct? And when it is losing electron, it is mixing with oxygen. So what this guy is doing, zinc is acting as anode. Anode is something which takes electron, right? So whatever extra electron it has given, this zinc will take it. Zinc will take it and it won't allow iron to get rusted. Correct? Because anode takes electron. So zinc will take electron and it won't allow iron to rust. Correct? See, iron has a tendency to lose electron. So iron will lose electron anyway, right? Now, if this electron is taken by oxygen, it rusts. If this guy is taken by zinc, it won't rust. So that is happening here. So the moment this extra electron which iron has loose is taken by oxygen, there is a rusting that gets Fe2O3. But the extra electron, whenever it comes, zinc takes it, then oxygen won't be able to take it, right? If zinc takes it, then that means Fe2O3 is not formed, and that's how it prevents rusting. Hope you understand this. The sacrificial anode, you can say, where zinc will take the extra electron. Zinc will not allow oxygen to take the extra electron. Correct? Now let's go and do understand these two methods, hot dip galvanizing and electroplating. So in hot dip galvanizing, what we do is we have this zinc, molten zinc. In this we dip aluminum. It's called hot dip galvanizing. In electroplating, what we do, we have this, I think we have discussed electroplating thing, where we have this aluminum here and where we have this zinc thing here, right? We have this zinc thing here. So it goes here gradually. So in this case, this is aluminum and this is made the cathode actually. And you have some anode and you put some battery in this, right? So what happened is this has some zinc solution actually. Let's suppose it has zinc iron in zinc sulfate form. Zinc sulfate, this guy has a negative electrons. It gets attracted and it forms a layer here. So if you see, this guy gets a zinc layer. Correct? Hope you understand this. You have this beaker. In this you have molten zinc sulfate solution, and then you pass the electricity, right? And this you get electrons here, electrons, and you have this zinc ions here, zinc ions, sulfate ions here. This zinc ion is attracted towards this electron, and this it gets in this it gets a layer of this. The zinc ion will get this electron and will become zinc and it will get deposited here. Correct? Now let's see the third process called alloying. Alloy is a homogeneous mixture of two or more metals, or a metal or a non-metal. Please note, alloy is a homogeneous mixture of two or more metal or a metal and non-metal. So you can have a metal non-metal combination, or you can have n number of metals combination also. Like you have metal plus metal combination this way, or metal plus non-metal combination. So this is alloy, right? It is prepared generally by first melting the primary metal and then dissolving other metals in a different proportion and then cool down. For example, I'll take some examples here. So for example, iron is very soft, right, and it stretches easily when it's hot. But when this guy is mixed with this guy, 0.5% or 0.05% of carbon, it becomes very hard and strong. And that is what we call alloying. So you have this, you take 99.95% of iron and 0.05% of carbon. You mix it in the molten state, cool it down, this becomes very hard. And alloying is a very good method of improving the property of metal. There has to be a reason why we are doing alloying, right? So it improves the property of the metal. For example, in this case, iron was a little soft element when hot. Then what we have done is we have put only 0.05% of carbon and it has become very hard and strong. Another example is when iron is mixed with nickel and cadmium, it becomes stainless steel. It doesn't rust. The rusting problem is solved just by adding nickel and chromium in a small quantity. Right? So that's what the alloying is. The beauty of alloy is you add a metal, the bigger portion has to be this big metal, and then add small portion of some other metals in the molten state, right? Everything is molten, and then you cool it down. The cooled down metal you get is an alloy, and it has very good properties. For example, steel. Steel has iron and small amount of nickel and chromium. With this, there is no rust. The rusting problem is solved. Iron is soft. You add 0.05% carbon. It's very, very hard and strong. That's what the beauty of alloy is. You add small amount of other metals or non-metals to it, and the property change. One more example can be this pure gold. So if you see, gold is 24 karat, and that's very soft. You can't even make ornaments out of that. If you make, you can break it with the hand also. So what we'll do is they generally add copper or silver to it and make it 22 karat. That is, they are adding impurities to it to make it 22 karat, and then the gold is strong. The gold is strong and you can make ornaments. Correct? So we have a new term called amalgam. What is amalgam? So if an alloy has mercury in it, it is called amalgam. So if you put even 1% of mercury, that alloy is called amalgam. So just a term we should know. So I just have put this. Now, conductivity of alloy is generally less than pure metal. Just please note, it is generally less than pure metal. Correct? So if you talk about conductivity and melting point both, conductivity and melting point both of an alloy is less than pure metal. For example, if you see the brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. They are not so good conductor, but copper is a good conductor. So in copper you add small amount of zinc, it becomes brass. Copper you add small amount of tin, it becomes bronze. They are not very good conductor of electricity as compared to copper. Also we talk about the melting points. If you see shoulders, that's the alloy of lead and tin. It has a very low melting point, and that's why you use for soldering, right? It melts easily. It has very low melting point as compared to lead and tin. So that's why the alloy generally has low melting point and it has low conductivity as compared to the pure metals. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.